Have you ever been ambushed by the tickle monster? You know, that moment when someone unexpectedly attacks your sides with wiggling fingers? It's a feeling we all know. A sudden burst of laughter and squirming. But why do we react this way? Why are humans so susceptible to the tickle monster's attack? It's more than just a silly sensation. Tickling is a fascinating phenomenon that scientists are still trying to unravel. It involves our nerves, our brains, and maybe even our ancient ancestors. So let's dive in and explore the science behind this uniquely human experience. Get ready, because things are about to get ticklish. Did you know there are actually 2 types of tickling? It's fascinating how our bodies respond differently to each type. The first type is called mimesis. This is the kind of tickling that feels like a light, feathery touch. It's that sensation you get from a bug crawling on your skin, or a gentle breeze blowing through your hair. It's subtle but noticeable. Mimesis doesn't usually make you laugh, but it can be slightly irritating. It's more of an itch that you feel compelled to scratch. Think about it. That itch you just have to scratch. It's a relief when you finally do. The second type of tickling, the one that sends us into fits of giggles, is called gargalesis. This is the kind of tickling that makes you laugh uncontrollably. This is the tickle monster's specialty. It's the kind of tickling that kids often experience when playing. Gargalesis involves a more vigorous touch, often in sensitive areas like the feet, armpits, or ribs. These areas are particularly ticklish. It triggers uncontrollable laughter and a strong urge to escape. It's almost impossible to stay still when you're being tickled like this. Why the difference? Well, each type of tickle activates different nerve pathways in our bodies, leading to distinct sensations. Our nervous system processes these touches in unique ways. When you're tickled, special nerve endings in your skin called mechanoreceptors spring into action. These tiny but mighty receptors are scattered all over your skin, ready to detect the slightest touch or pressure. These receptors are designed to detect touch, pressure, and vibration. They are incredibly sensitive and can pick up even the faintest of sensations, sending signals to your brain almost instantaneously. Think of them as tiny sensors sending messages to your brain. Each time you feel a touch, these mechanoreceptors are hard at work, ensuring that your brain gets the information it needs to react appropriately. In the case of gargalesis, the signals travel to a part of the brain called the somatosensory cortex, which processes touch. This area of the brain is like a map, pinpointing exactly where on your body the tickle is happening. But that's not all. The signals also zoom to the anterior cingulate cortex, an area linked to pleasure and social bonding. This dual processing is what makes tickling such a unique sensation. This explains why tickling is often associated with laughter and playfulness. It's not just a physical reaction, it's an emotional one too, bringing joy and connection. It's a way for us to connect with others and strengthen social bonds. Tickling can break the ice and create a sense of camaraderie among people. Some scientists even believe that tickling played a role in the development of social behavior in early humans. It might have been a way to build trust and cooperation within groups. Imagine a group of our ancestors bonding over a tickle fight. This simple act could have helped shape the complex social structures we have today. Here's a question that might have you scratching your head. Why is it that we can't tickle ourselves no matter how hard we try? If tickling is so powerful and can make us laugh uncontrollably, why can't we tickle ourselves and get the same reaction? Try as you might, you'll never experience the same sensation when you're the tickler. It's almost like your body knows it's coming. The reason lies in a clever little part of your brain called the cerebellum, which plays a crucial role in this phenomenon. The cerebellum is responsible for coordinating movement and predicting sensory feedback. It helps us move smoothly and react to the world around us. When you try to tickle yourself, your cerebellum is one step ahead. It predicts the sensation and prepares your body for it. It anticipates the sensation and sends out a canceling signal to the somatosensory cortex, the part of your brain that processes touch. This dampens the tickle response, leaving you feeling strangely untickled. It's like your brain is saying, I know this is coming, so no need to react. It's your brain's way of saying, don't worry, I got this. Pretty neat, huh? So next time you try to tickle yourself, remember your brain is always one step ahead. While the science behind tickling is fascinating, there's another side to tickling that can't be ignored: the social aspect. Think about it. Tickling is often a shared experience, a playful interaction between people. It's a way to bond, to show affection, and sometimes to establish social hierarchies. Tickling has been observed in various social animals, including primates, where it often serves as a form of social bonding. In humans, tickling can strengthen relationships and create lasting memories. When we tickle or get tickled, it's usually in a safe, trusting environment, reinforcing social connections. Interestingly, the response to tickling can vary based on the relationship between the tickler and the tickly. Tickling from a close friend or family member is often met with laughter and playfulness, while the same action from a stranger might be uncomfortable or even unwelcome. This highlights the importance of trust and familiarity in the tickling experience. So, the next time you find yourself in a tickle fight, remember, it's not just about the laughs, it's about the connection you're building with those around you. Thanks for watching. We hope you enjoyed learning about the science of tickling. Don't forget to like, share, and subscribe for more fascinating content.